So let's do this. Let's go to Q&A. Let me start with Eric Hermanson. Eric, go for it, sir. And he just disappeared. Wait, did I hit the wrong button? Okay, that vaguely terrifying. Okay, so I guess who has a question next? Oops. Okay, so let me go and allow participants to unmute themselves. Michael Boyd, sir, go for it.
Hey, Mike. So I got a question, but I put, if you would you go into the chat, and I put a circuit drawing for you. It's at 2 minutes before 3 p.m., which I assume that's my time in California. So it's what's called a self-resonant battery circuit.
Okay, that sounds interesting. I don't know how to get chat up here, so I would have to
You know what? I see that, actually I see that in chat. So yeah, Mike, it should be down at the bottom. There should be a little chat icon. See that green share screen button?
Yeah.
Right next to right next to that. There's a little button labeled.
Says chat. Okay.
Yeah, it's labeled chat. That'll pop it up, and then you may have to scroll up a little bit. Yeah, so you could probably save that for later. But Michael, is there anything you could describe for us about that?
Well, it shows it's supposedly based on Tesla's design, and what it does is it uses a self-resonance between 4 batteries, so that they can achieve what's called over unity. So they'll produce essentially more power than the more power, the bigger the load, the more efficient the battery becomes.
Okay.
I got it open, but it says it won't let me do anything. It says the administrator has to do it.
Oh, okay. Hey, maybe you could open it, Tim. You're the administrator.
Oh no, well, let me see here.
Either that or throw it in my email. That always goes through.
Show in Finder. Hang on. So let me upload. Let me see if I can re-upload this thing. Okay.
So, Tim, I don't want to monopolize my time. Could you guys
there we go. Yeah, I just uploaded it too. It's just a JPEG image. So, but yeah, that's there in chat. Okay, so Michael, thank you, sir. Let me go to Harold Tavares next. Then.
Okay, let's
Harold.
Yes, Mike, I have a question for you. Granted that the internal combustion engine with a drivetrain is the most successful and best-selling propulsion system of all time. Now, if Tesla created all that and it's that good, very promising, what you just described, how come, modern manufacturer like Tesla, the electric car, they have not duplicated the initial Tesla system to bring it into the market today, especially when it will help the environment and the global situation on the climate change?
Well, I would love to see it done. I'm working, this is one of my side projects, along with gyroscopes on propulsion systems. Where I started on this, one of my engineering buddies brought in a book about Tesla, and there was a chapter in there about this electric car that he built, and it really got my enthusiasm and interest. And ever since then, I've been working on it. I've spent 5 years of engineering on this thing, and I'm just starting to show reasonable gain on the thing. I present this at the Tesla Tech conference every year for the past 5 years. 4 years before I could get break even on power. Last year, I made 5 watts. So it's not easy because of the resonance, which is probably why nobody has worked on it. Now, you're having similar problems with your lifter systems in resonance, and it's pretty much the same
Oh, Mike, I just did a
We
request for you
dropped
to
out.
start.
Yeah, we dropped out here. Hang on a minute.
There we go. There we go. You're back. You're back.
But yeah, anyway, it's also not that well known. A lot of books on Tesla don't even mention it. If you look it up on Wikipedia, they say it's all a joke, that it never happened.
Okay, and so that means that on one side they say it never happened, there is no evidence, and the other side there is some evidence because you are presenting a logical explanation that makes sense that it may be true. I mean, what side are you on? Do you think, you know, that eventually if the resonance problem is the issue, why we don't have it today? But obviously Tesla, when he did it with his car, did not have that problem. So where is the disconnect there?
He's the expert.
Yes,
Okay.
Tim, it's John Reed. I have a question for Mike
Thank you.
Gamble.
Yeah, jump on in, and then I'll go to Eric right after that. But yeah, go for it, John.
Yes, Mike, I had to step away from the presentation, which was excellent, a couple of times, and I may have missed it. But the antenna that you're speaking about that you made your model with, were you designing that to receive electromagnetic waves, or did you try to look into some other form of energy input? You know, some people claim the ether or some other form of energy input besides electromagnetic waves. And I'm wondering if you explored any of those alternatives, or if you were just looking for electromagnetic wave input.
To start with, just plain electromagnetics.
Okay,
Before I go to the fancier stuff, we get the basics down.
sure. But maybe I was wondering, you know, a lot of people have claimed that Tesla's engine was working on
Scalar
something other than electromagnetic waves.
Scalar waves.
Yeah.
Yeah.
Uh-huh.
Well,
Do you know of anyone who's been exploring those alternatives?
no, I don't know of anybody that's pursuing his electric car or resonant electric motor car system except me. I would love to find, there's a couple guys that are trying to duplicate it. I talked to them last year down at the Tesla Tech conference. They want to try and duplicate my numbers. And I says, I'll be happy to help you as much as you want, because everything I publish here is in public domain. I don't try to hide anything.
Thanks so much, Mike.
Yeah, Mike, thank you. Let me go to Eric next.
Oh, hi, Mike. Thank you very much. I had a really quick question first, because I did want to talk about the antenna. What's the frequency of the photons that the Kinetic antenna is tuned for?
Well, the antenna is tuned for 60 hertz.
60 hertz?
Yeah.
Okay, so it's going to pick up photons with the 60 hertz. Okay, so I'm just looking at a frequency chart here, very, very detailed one. I just wanted to know what else is in that range.
If you go higher, you get a lot. If you put a spectrum analyzer on an antenna and just do a sweep, if you get up into the radio band or the higher kilohertz, you get much more energy floating around to grab than at 60 hertz, which is one of the problems.
I was just wondering, is there anything possibly supplying the energy from a conventional source? When Tesla was around, there was no cell towers, of course, but even with cell towers, that's not going to give you that much energy. It's not concentrated like that. But the main question is, and this might sound like a dumb question, but I really don't think it is, for several reasons. Did Tesla, or have you, or has anyone ever tried to test this in as tight or as pure of a vacuum as possible? I know that you'll say it'll probably still work, but just have you ever tried it?
I wouldn't even know how to do a vacuum unless you got in outer space. I've done a few experiments up on the space shuttle where we grew stuff up in space, but I don't know how you get this up there.
Well, I don't know. I don't work with vacuums very often, but it just seems like if you had a vacuum that's large enough and powerful enough, you could get a pretty good vacuum on Earth. Just stick it right in there.
Well, Boeing's got some big vacuum chambers I've worked with. You can put satellites in them, but I don't think it would do anything one way or the other for this.
Right. Okay. And
It might
I know
work
that.
if it had a steel cage, it would probably work as a Faraday cage, in which case it would probably wouldn't work at all because it would short it out.
Okay. Thank you.
Yeah, and thank you, Eric. Let me go to Michael next. Michael?
Hey, Mike, I sent you an email with that file attached to it.
Okay. I'll dig into that when I put the Zoom down. I can't get it
Oh,
open
you
right
can't see
now.
it. Would it, Tim, would it be possible for me to share that?
Well, yeah, if you got it up on your screen.
Well, I could do it, but Tim has to.
Yeah, I
enable-
know, it's got to go through him. Yeah, I know.
That's the problem. So,
I'd be curious to look at it and see.
okay, well, let's do it. Just do it offline. We got, what I'm asking about is basically is this something you think we could reproduce? I have a number of the components that I've purchased, and I've been trying to figure out from the circuit diagrams certain of the semiconductor components, if we can get those components nowadays, because there's some circuits there that I'm not familiar with, that I was hoping that maybe you could understand the symbols they're using. Okay.
I'll take a look at it. Anything that mentions Tesla usually gets my interest. I'm very curious on the work he's done.
Yeah. Hey, Tim, did you get my message that I sent you?
Sorry about that. You emailed the circuit image to Mike, and could I let you screen share?
Yeah, because he can't
screen share it. Yeah, go for it. Go for it.
Okay. Do you see that?
Yeah, well, I see a blank screen with your name on it.
Oh, you don't see you don't see the circuit?
Nope. There you go. Okay.
You see it now?
Yeah, I see it now. You got 4 batteries. Okay. And it looks like you got a round robin system, rectifier bridge for a load. A lot of big capacitors in there.
And it looks like in the middle there, you see timer input.
Yeah.
I assume that's like it's some kind of square wave that's going into the thing to.
Well, yeah, you got a whole
drive
bunch. Yeah, these the 4 transistors there. You got AC coupling through a transformer coupled, and so there must be a sequential deal there from looking
Right.
at it.
So basically, one battery's discharging while the other battery's charging, and they're basically going in a loop pattern.
Yeah, it's a round robin system.
Right.
Yeah.
And
Yeah,
so-
this is similar. It's gonna have phase locking with the 6 coil segments in the middle, so it has to be an odd number, like 5 or
Yeah.
7.
Yeah.
This is here in the moment. I'll show you what I've been working on, which I've been.
5 there. I see 5.
Well, I don't know. Let's see. There's 1, 2, 3, 4, 5, 6. Like if you go to the timer input, you have your first coil.
Okay, let's see.
System 2, second, third, fourth, fifth,
Yeah,
and
I see.
6th.
Yeah, you're right.
So that you'll have the waveform will get caught, or it'll get phase locked within the with a even number. So it's like that's something I had to stumble across or was working on the Manellis circuit, which is similar to this. So I'll show my thing here in a moment.
Okay, well, I just I'm just curious. I'm just want to see if there's something I can build to make a better battery.
Yeah,
that's all I was asking about. I'll stop my
you got a
share.
lot of power diodes there for switching that heavy current. So
Well, where's the, what do you mean? You're talking about the input voltage has to be a hefty current?
well, the output of the batteries is going to be like 400 amps. You know, I'm assuming these are car batteries.
Right,
Yeah,
so,
so
yeah,
you got those diodes that have to handle 400 amps at 20 volts. So you're going to have some pretty hefty diodes in there. And the transistors are probably going to be handle half of that, just looking at it. So
right.
I don't know
but
why
then-
they're transformer coupling. I don't understand why they want to transformer couple them unless there's some phase lag due to the transformers.
Yeah,
Because you can use optical couplers, which is a lot easier.
huh. So maybe there's a way to reproduce this with more modern components.
Well, yeah, the old way of isolating transistors or any electrical system was, transformer coupled, but optical couplers work much better. I mean, you can go 4,000 volts with those things.
Oh yeah, I've used them before. No, they're real high voltage and they're fast too.
Oh, yeah.
Yeah, no, I agree. Yeah, this looks like that's why I was saying. I mean, just look at the bridge, how they drew the bridge.
Yeah.
That kind of tells me this is some old circuit design.
Well, that's true.
So okay, thank you for that.
It would probably work, and if I had a little time to play with it to figure out what it does, it's a round robin sequencer of some kind.
Right.
I had to figure out what the switching logic on it. There's a lot of diodes that are being used as OR gates.
Right. Well, you got the drawing in your email.
Yes.
So okay, thank you for your time. I appreciate it.
Mike,
Yeah.
it's John Reed again. I just had a quick comment. You'd mentioned earlier in your presentation that you had a hard time finding some items, and probably others have, publications, old publications and that kind of thing. And I don't know if everybody knows about it, but there's a website called AmericanRadioHistory.com, and they have hundreds of all of the old technical manuals from the early 1900s up through the 50s, etc. Virtually anything that's ever been published on radio or technical aspects of any kind.
That's where I got the Ignitron data. It only went back to 1938.
Question, do you guys have access to any old radios that might have any of that legendary red mercury in it by chance?
I don't think radio's ever had red mercury. I think you're thinking of some red mercury was something completely different, Bernie.
No. I'm talking about, but it's mostly over in the former Soviet Union ones, but they're from like the 1920s. There's a couple of YouTube channels that pull it out, and it's right by the antenna that there's these vials of red mercury in them.
Well, there are some old tubes that had mercury in them. Ignitrons were one, but there were also some amplifier tubes way back in the early days that had mercury in them. But I don't know about red mercury, but just
no, red mercury is and that's mythological anyways. That's like, what do they call it, a white unicorn? But yeah, no, what I don't remember what the idea was. Red mercury was supposed to be some kind of nuclear explosive type thing.
Well, that's the stuff the Germans used in the Bell.
Yeah, supposedly.
Tim,
if anybody could make it.
Some videos from Conspiracy Land.
Can we get that URL again? I'm actually shopping around for a manual for some equipment here.
Is that the unihedron? Is that Eric posted that one? Yeah, I think that's in chat, Mark.
The one for
American radio history.
American radio.
It's
Oh,
I'm sorry, I was off. I was on mute for a minute, and it's called AmericanRadioHistory.com. All
Okay,
all one word, and like I say, it has virtually everything that's ever been published on radio transmission, radio waves, back to the late 1800s, really.
AmericanRadioHistory.com.
AmericanRadioHistory.com.
Yes.
Yeah. Well, so let me see who would like to ask more questions. Let's take a look here. Other than URL related questions, because we're putting all those in chat. I've got lots of them in chat here.
Bill's waving his hand.
Oh, is he? You see, okay, this is a Zoom thing. I can only see like the first 5 people on the screen. Everybody after that, I can see you, Mike. I can see who's speaking. I can only see the first 5 people. Yeah, go for it.
Yeah, hi, Mike.
Howdy.
Yeah, good presentation. You know, in the mathematics, when you look at, you know, some of these resonant situations here, that when you're at a resonant frequency, your resistance becomes dominant. Okay.
Yes, sure does.
But with these type of systems, you know, where the phase between the voltage and current has to be 0 degrees, but in these type of systems, it's not. It's the system has to be like 90 degrees out of phase.
Yep.
Between the voltage and current.
Yep, sure do.
And that's where you see this effect occurring.
Yes, that's the secret ingredient.
Yeah. And, you know, when I looked into Tom Bearden's work, you know, I'm not sure if he brought it up, but I've been hearing this term of the law of squares. I don't know, have you ever heard of that law of squares? Like in a John Searle work and
Well,
Yes,
Some
the
of
law
these
of
other-
squares is
with-
mathematics.
With
It's,
mathematics,
law-
but not in the real world, you know, or the application thereof.
okay, well, the law of
It's kind of a
squares,
quantum, right?
where that comes in at is opposing forces with electric and or magnetic charge. In electric fields or magnetic fields, you have to have this opposing field action. And what comes into play is this law of squares. And it's like the conventional equations no longer apply, that now you're working with the scalar component, and Tom refers to it as the gravitational field component. Okay, that's what really comes out of the scalar work, are gravitational waves. And when you get to this resonant point, you know, as I mentioned before, it becomes dominant. Okay, the effect, you don't see that scalar effect if you're outside of resonance.
Yep.
Okay, it becomes a conventional system. But when you fall into this resonant situation, then the dominating component there is this gravitational component, because you're actually pumping the field.
Yep.
Okay, it's either the
And
electromagnetic field or on a mass, and that's where this thing about what Tom spoke about, you know, in his lectures. And then you get this new form of electricity that seems to come out of this. It's like a longitudinal electromagnetics, which seems to come out of this. And it's a whole different set of rules that seems to apply. Okay, and that's what we see in our tech. Okay, is this, it seems to be like another form of electricity. Okay.
Is this like Tesla's cold electricity, for
Yes.
instance, or plasma-based electricity?
Yeah, yeah, because you're not working with conventional field theory. You're working with something that's like 90 degrees out of phase. And that's why you have no temperature in space. Okay, because you're working with an impedance. We know what that impedance value is, but there's no temperature associated with that field. There's no temperature in magnetic fields, you know, for example. And that's what I find really fascinating about this. And so this concept of law of squares seems to come into play when you set up these opposing field action and this what's called longitudinal electricity. And so that's a whole area that has to be explored.
I just to add in I've seen those same mathematics in Marco Rodin's vortex-based electricity and mathematics a lot too. the
Mhm.
law of squares.
Yeah, well,
playing
he's
out
working
into
with,
it.
like Tesla worked with converging electric fields. Rodin is working with converging magnetic fields. Okay, so that phenomena is going to show up. And when you set that system in resonance, then a whole set of different rules seem to emerge out of it. And what we see coming out of this is, really weird stuff. I mean, it's not conventional. It's not simple. It's like a whole set of other of mathematics seem to come into play here. And conventional theory, it doesn't show up in conventional theory. They say, well, you got the zero vector, but there's no scalar component. They took it out of the mathematics. But if you put that scalar component back in, guess what? There's your gravitational component. And if you put energy into the system, it becomes gravitational. If you take energy out, it becomes anti-gravitational. Okay. And that's what we see in like the Floyd Sweet device, and these various devices that people came up with over the years. So, and your waveform is going to look very different, as well. You'll see a conventional voltage sine wave, but then the current waveform is going to look very different. Okay, it's going to look very different. And you try to analyze that conventionally, and everything just falls apart. You can't do it. So you have to go back to the old mathematics to see, aha, there's that scalar component that comes up. And it works perfectly. Okay, the damn thing works perfectly.
Yeah.
So I just wanted, to mention that you can't use conventional modern physics to solve gravity. It just doesn't work. It's not there. It's been taken out. So I just wanted to make that comment, about this.
Yeah. Well, thank you, Bill. Thank you. And so Mike, I don't know if you have anything there, or if we should go, should we go next question, or we'll go next question. Who has another question for Mr. Gamble?
Mike,
Yeah.
what became of that car, the Pierce Arrow, in history? Did anybody buy it? What became of that car? Do you know?
I have no idea. The last, if you read those stories, it was stored in somebody's barn, and that's the last anybody heard of it.
Boy, that would have been an interesting find, getting that car for all the history behind it. Well, too bad.
Yeah.
Too bad nobody found it. Hey, thank you. Great presentation. Good information. A lot of inspiration there for future research on Tesla technology.
Yeah, well, that's what I spend my hobby time on, is anything Tesla.
Well, keep
Well,
on at it. You're doing good.
Let me see. Let me go back to Michael Boyd.
So my question, Mike, do you think that there's a relationship between, or what do you think is a relationship between a standing wave and self-resonant states?
Well, that's the standing
You
wave
think they're
is
equivalent?
self-resonance. As long as the wave's traveling, it doesn't have a chance to build. But once it's stationary, then each cycle builds upon the previous cycle, and it just pumps itself up.
Now, isn't that how a linear accelerator works?
I think so. I'm not much on nuclear physics, but I believe that's how a lot of cyclotrons and stuff work. They just keep running in circles, and each time around the track, it gains energy.
Cool. Thanks. That's my question.
Did Tim disappear?
Counting on me.
Hi, Mike. Go ahead. I just have a general question, not specific to the conversation or to your presentation, which was very good, by the way. If I could have some time to talk about it, if now's a good time, or I can wait till everybody's questions are done.
Well, go for it.
Well, Mike, I've learned a lot from you, sir. You know, when I first came on these conference calls, I'm a little bit shy. It's kind of hard for me to loosen up and start just talking my heart out. But because I've got some issues, but I've worked through those. COVID's been hard on the family. I lost the love of my life in September, went through some stuff. I was hoping to see you guys at Tesla Tech because it was here in Albuquerque. I'm only like 40 minutes away from Albuquerque now.
Well, I'll be down
but anyway,
there.
I'm making a big move.
Steve,
Good. I want to see you. Well, I'm making a big move this year. I'm moving out of my shell. I'm the gravity alchemist, I call myself. I'm coming out of the closet this year with a propulsion device that I'm making big claims about. And I've already incorporated, I've made an LLC. My CPA is on board with me. My CPA's son is a master's degree in electronics, and he builds propulsion systems for the Navy for certain things. But, and I explained this to him, and he's pretty on board. He's just got to find out that it's not a conflict of interest with his being a subcontractor to the Navy. My idea is real simple. You guys are, you guys have a lot of knowledge about theory, waves, all this. Mine, and I explained this in detail, and I talked to Ron Keto about, I talked to you first about liquid momentum wheels. You didn't have a lot of information, but Ron did, and Ron says, yeah, liquid self-balances when you spin it in a torus vessel.
That's
so
true.
Without, nobody wants to sign any NDA agreements, and my SCORE advisors told me I got to get NDA. Now I'm looking for someone, because I've also hired a grant writer. So I'm going all out with this. I'm going to get a grant either with SpaceWorks or seed fund from National Science Foundation, the Navy. I don't care. I just need some funds to move ahead with the project. And because I am excited about it. And I'm going to send you guys a link in the chat to my landing page. You were talking about in 1926, my grandfather built a gyro motor just 70 miles south of Goddard. At the same time Goddard was building his rocket. I've got pictures of it on my website now. I've got pictures, I've got newspaper clippings. I got everything about my grandfather's gyro motor. It ran on gas, it ran on air, it ran on oil. You can see the newspaper clippings. So, I mean, he was a big deal. He was a big deal. And that was my own grandfather. So I know where I get all these ideas from. They're coming from him, I guess, genetically, because I sold insurance for 44 years. And when I got out of insurance, I look back and I think, I'm glad I don't sell insurance, but I love science. So I've been educating myself. So when you told me that when a reaction wheel is running on a satellite, it always rotates around its center of mass. Well, my system, I figured out how to change the center of mass in a spinning disk, bifurcate it from its center of geometry without violating Newton's third law. And I can do that 50 or 100 times a second.
Mm-hmm.
Now, how far I bifurcate
force.
the center of mass from the center of geometry and then rotate it 1 pi radian, it moves that far in Cartesian coordinates. And if you do that, like if you did that a foot and you did it 32 feet, 32 times a second, you've got a Newton force equal to Earth's acceleration. Now I'm talking about Einstein's idea of what acceleration is. It's just a. Einstein said it was a pseudo force because of time, the bent time, space, and all that with mass. But Mine's more just looking at it from a Newtonian perspective. And basically, it's what my grant writer's telling me is that I need a physicist on my team that will sign a non-disclosure statement. And I have the non-disclosure statements. I need a physicist. And I'm waiting for this master's degree electrical engineer to see if he can do it. He wants to. Like I said, his father is my CPA who just incorporated me. I incorporated myself as Southwest Creek Engineering and LLC. And so my CPA's dad retired from JPL, and when he retired, they gave him a plaque with a moon rock on it. I mean, and they say, "You remind me exactly of our dad." So, you know, I like propulsion. This thing, I really have a good feeling this is going to work. And I'm reaching out to the community. I'm reaching out to you guys, anti-gravity. Do you guys assist scientists, engineers, experimenters? I guess I'm an experimenter in helping to build the next generation of technologies. Well, I'm boldly saying right now that my idea is going to work. And I remember I talking with you and Tom. And I said, Tom, mine will go from launch on the surface to orbit, and it doesn't have to reach escape velocity.
Bill, it's John Reed here. I just had
yeah.
Yeah, I just had a quick question. Have you,
yes, sir.
Have you built a working prototype model by chance?
No, I have not. It's hypothetical right now. I've got it all in. I built a demo model to show this electrical engineer to explain how it works. So this is my claims. The motor runs on electrical energy. The motor reduces the complexity of construction compared to rockets. The motor on the spacecraft can accelerate the craft to attain a position in space without reaching escape velocity, as long as there is electrical power. The motor makes a spacecraft hover by balancing the Earth's gravity with a linear Newton force, pulling the craft 9.8 meters per second in the other opposite direction. And the motor does not violate Newton's third law of motion. Now that's my novelty that I figured out. How do you get around? You can't get around Newton's third law of motion. It's a law, man. But there is a way to bifurcate the center of mass from the center of geometry without violating Newton's third law. And that's the whole thing why this would work. And the motor can accelerate a spacecraft faster than 10 meters per second squared. The motor can accelerate a spacecraft in friction or frictionless environments, such as microgravity, without mass ejection. There's no mass ejection. The motor
is that based
in space
on the
no
previous
harmful effects on
presentation you
occupants due
gave?
to-
Yeah. Well. So let's try and rein this back.
I'm not giving it away.
Well, no. Let me try and bring this back into Mike's presentation now.
I'm just trying to. I'm almost done.
Oh, okay.
Okay, I'm sorry. I'll talk to you guys later. But if there's somebody that wants to reach out,
I believe in
and
you,
we'll sign an
William.
NDA.
I believe in you.
Well,
don't
yeah,
listen.
William, I would say,
Say
you know,
again?
we have the open discussion. We do have the open discussion coming up, and
Well,
so
you guys think because I don't have an education, that maybe that I'm not giving
William,
any
it's
respect.
nothing
No.
like that at all.
Rodney
It's,
Dangerfield.
let's finish this discussion in an hour and a half after the presentation is done. is all
yeah,
I'm saying.
yeah, William, that's all. I'm just trying to focus it back
Okay.
in on Mike. That's it. We've been, you know,
Okay, well, I'll talk to you guys later. I already asked Mike if it was okay. He didn't seem to object. Okay.
yeah,
Well,
yeah,
like
I know.
said,
Well,
I'm-
and it's
I'm a little
good. I
shy.
just,
You know, this was being really vulnerable to you people. So.
oh no,
I
it's
think I'll
fine.
just,
It's fine. Yeah,
find another-
I just want to I want to focus it back in a little bit so that we get them all this time for the
Well,
Q&A.
go back behind
So-
the wall. We're just saying we have one more presentation scheduled. Then it's open ad hoc parts where we can go in and talk for hours on what you are saying because there's much substance to it.
Yeah.
And thank you for coming
Okay,
out.
I'll send
with
you
it.
guys a link, man. I got to
Yeah,
cut out.
yeah, put it in-
I've
put it
gotta
in
jump.
chat.
Thank you.
Okay. Thank you again, William.
Thank you.
Okay. So
You
let
bet.
let me go back and see, do we have more questions for Mike? I know today we've been.
One question for Mike.
Yeah, go for it, Harold.
Okay, Mike, can you discuss the Boeing is using the electric motor with the power supply, Tesla power supply that you were discussing right now? Are they using that in space to power some of the gyroscope with that electric motor, with that setup, as you just described?
I don't think anybody's using it. They run gyros with electric motors in space, but their power is coming off a solar panel. This resonant power system that I just presented here, I don't think anybody's working on it. I would love to find somebody that's working on it to work with them. Two heads are better than one.
How long ago did you get that particular idea?
I've been at it 5 years.
Oh, okay. So you did not get it when you were working at Boeing.
No.
If you would have been working at Boeing, if you would have got that idea, the resonant motor system that you discussed now, let's say 10 years ago when you were, or 15 years when you were at Boeing, would you have used it to power a gyroscope in space?
I don't think Boeing would even be interested in it. They go for fairly conventional stuff. Anything like weird science, they're not really interested in.
All right, thank you.
I couldn't sell them. I couldn't sell them my flying saucer engine from last pitch. They weren't interested in that either.
Oh, okay. Thank you. Very honest answer. Thank you.
And Harold, thank you as well. Let me go to Nils now. Nils, sir?
Yeah. Thank you for Mike for the presentation. We're both engineers, and I assume we both agree that having a resonant circuit perfectly resonating, or even going with the Alex idea of voltage and current 90 degree out of phase will not produce any extra power. It will always produce less than what you expect.
Well,
and my question about the Tesla motor or the car, did he have a transmitter nearby, near his house or something?
That was my last chart. Who's transmitting? Last year, well, 2 years ago, I broke even on power, that the power in equaled the power out. Last year, I was 5 watts to the good. The input power is 5 watts less than the load. This year, I'm trying another method, and I will be presenting that down at Tesla Tech in August. If I get it running by then, that's my goal.
Right, but you know that 5 watts out of a 1,000 watt device, that's a very small percent. That's 0.5% or something. So you could just have a measurement error. You know, what is the 5 watts?
It's 5 out of 30.
Oh, 5 out of 30. Oh, okay, that's significant. That's significant.
Yeah.
Yeah.
I'm
But
shooting for a bigger
the
number
Tesla
this
didn't
year.
have any transmitter near his car when he was driving?
Nope.
Interesting.
He called it ether power.
Mike, do you know what frequency he was at? He was at 60 hertz?
No, I think he was up higher. That's one of my proposals in the modifications. I think he was running up higher.
You think
60 is very hard to get components to resonate very good.
Do you think he could do 8 hertz? 8 would be difficult, wouldn't it?
I don't think you could get the problem is the parts get so big as the frequency goes down that the losses kill you.
Well, the reason I asked was when I was, God, that was a long time ago now. When I was in college, my college library had a book on the Earth's electrical system, and they had stuff in there by Tesla, and they were talking about 8 hertz as the natural cycle, and he was playing with that. So
that's my gravity pitch right there.
Yeah.
7.06.
Yeah, I think that was probably what it was. Yeah.
That's the von Karman resonance, and that changes. It's or no, excuse me, not von, the Schumann resonance. It
5
changes.
harmonics.
It goes from like 6 up to 12.
5 harmonics. 5 harmonics.
There are 5 harmonics in the Schumann resonance.
Yes.
Or Okay, I mean, I've studied or I've watched that Space Weather News presenter, and they've, the L shells are around the planet, or Van Allen belts are part of that. And so like
Yep.
when the
You may-
planet gets really whacked with, well,
you didn't
really
see
hit
my
with a
gravity
strong
pitch a few
CME.
years ago.
Yeah.
Oh, okay, like
Sorry,
So
we're getting a
Mike,
lot of
can we
echo on
see
Mark's
the-
lab.
thread.
Mike, can we see the-
Okay. But yeah, anyway, it's just the von Neumann resonance. I know it's from, it fluctuates, and there's a couple people out there that are watching, or they have it on. There's websites for it. So yeah. All right. Anyway, I yield.
Mike, do you have the circuit for the 5-watt device online anywhere? I can study up on it.
I don't have it online, but Tesla Tech last year's presentation has a video of it.
Okay, I'll check it out. I'll look for it.
I could send you a copy of the pitch if you wanted, but if you get the video, you get the more of the presentation, because it's like this one, just having a piece of paper doesn't tell you a whole lot.
Yeah, that's true. Okay, so I can find it online through the conference
Tesla Tech.
link?
Yeah, Tesla
Okay.
Tech.
Or do I have to pay to subscribe or something?
You can, teslatech.org is the website,
Okay,
but if you send me your email, I can email you a copy of just the pitch, but that doesn't tell you, as much as you get from the video.
okay. All right, I'll check it out. Thank you.
Okay. Nils, thank you, sir. Let me go back to Michael Boyd.
Hey, Mike, so I sent you another email, and what I'm asking is why batteries recover after a load is removed?
No, but it's probably something with a spike.
So I think it has to do with the chemical reaction in the battery, but
Yeah.
it seems to be a factor that applies to capacitors as well.
You get a spike or a pulse when you put a load on or remove a load on electrical system. I guess you would call it electrical inertia or something like that.
Yeah. So what I'm asking about though is if that would be a possible way to create a resonance, because there's going to be a time factor there.
Well, that's what I showed in that inductor capacitor circuit, is you have to have a little bit of current flowing into the thing to kick it to get it going. And then if you get it tuned right, that's when you get the big power.
Right. So I'm wondering if that's part of this over unity in that other prior circuit drawing I showed you.
That is probably how it works, is by doing a round robin type system where each battery picks up the load, and then it's disconnected, added, disconnected, added, that those spikes are starting to add up.
Right. So it reaches a certain peak, and then it switches
Mm-hmm.
to the next battery.
Yeah,
in
it
the
just goes
chain.
around in circles.
Gotcha. Okay. Thank you.
Wonderful. Okay, so who else has questions for Mr. Gamble? And we are getting close to the top of the hour, so we could, if nobody raises their hand, we could I could just start on the Hutchison thing if you want.
Go for it.
Okay, well let me do that then. I'll put this back on gallery. Everyone, please give Mr. Mike Gamble a giant applause for a wonderful Q&A session, as well as a detailed presentation. Thank you, Mike. I sincerely appreciate it.
Well, I appreciate being allowed to pitch at your conference here. You seem to have me back fairly regular, so.
Yeah, well, you have a ton of material and it's really great. It's really detailed.